Vidya Shankar. He completed his B Architecture from National Institute of Technology, Tiruchirappalli. He did his graduate training with architect Kukke Subramania, Bangalore, which was his initiation into the design practice. He then went on to pursue his Masters in Architecture from CEPT University, Ahmedabad, specializing on architecture, theory and design. During the years 2007-2010, he was working as an associate architect with the architect P.G. Sivakumar, Tiruchirappalli from Tamil Nadu, where gained design experience on varieties of projects ranging from college campuses to small residences. He then scaled heights by working with the architect Dean de Cruz, Goa, during the years 2013 to 2014. He received the opportunity to work on projects of intense design explorations with a master architect on varieties of projects including an art gallery, boutique hotel, housing and residential projects, all in Goa. Today, Vidya Shankar stands to be an esteemed visiting lecturer at few reputed architectural schools in Trichy, where he continues his academic interests through teaching.
Welcome to the UGC lecture series. We will be seeing the subject Theory of Architecture 1. We will be discussing the unit number 5, what is called as the Principles of Architecture. In that we will be seeing in detail about the ordering principles of architecture. The contents of the discussions are an introduction to what is meant by the ordering principles, and we will be seeing the ordering principles one by one in detail. First, the principle of axis, then the symmetry, what is called as the hierarchy, the rhythm and datum. Introduction to the ordering principles of architecture. What is called as order? We see certain examples of history in modern architecture. We look at the building, we see some sort of an order or a perfectness or beauty in the building. What creates this harmony or beauty or perfectness in the building? What goes into the designing of it? That is what is called as order, and that is what we are going to see in detail in this discussion. We see a quote about order now. Order must be understood as indispensable to the functioning of any organized system, not only architecture. Neither an engine, nor an orchestra, nor a sport team can perform without the integrated cooperation of all its parts. So, a work of art and architecture cannot fulfill its function and transmits its meaning unless it presents an ordered pattern. So, it is not only for architecture. For any field, for a music or for a sports, every part has to have an order to work together, and that is what brings perfectness and beauty to it. Order refers not simply to the geometric regularity, but rather to a condition in which each part of a whole is properly disposed with reference to the other parts to produce a harmonious whole. A building or a space has different parts to it. All the part has to have some sort of a relation and connection to each other, and also has to work functionally as a whole harmoniously. The principle behind it is what is called as the order. We will see certain principles, basic principles of order. The axis, which comes the first primary principle, axis, symmetry, hierarchy, datum and repetition. What is an axis? Axis is a line established by 2 points in space, about which forms and spaces can be arranged in a symmetrical or a balanced manner on either side. Symmetry, the balance, distribution and arrangement of equivalent forms and spaces on opposite sides of a dividing line or a plane, or about a center or an axis, is called symmetry, like what is shown in the picture. You have a central line and you have forms and objects on either side arranged in a similar manner. Hierarchy. Hierarchy is the articulation of the importance or significance of a form or space by its size or shape, or just the placement relative to the others in the organization. Rhythm. Rhythm is a unifying movement characterized by a patterned repetition or alteration of formal elements or motif in the same or a modified form. datum. Datum is a line or a plane or a volume that by its continuity and regularity serves to gather, measure and organize a group of forms and spaces around it. We will see all these principles one by one in detail with architectural examples. We have to keep in mind all this principle is not only for architecture, even for art like sculpture and painting. We have all these principles that can be applied that makes a painting harmonious, beautiful or functional. Now we will see about axis. Axis is a line established by 2 points in space about which the forms and spaces can be arranged in a symmetrical or a balanced manner. Although imaginary, an axis can be a powerful dominating regulating device. Like what you see in this picture, the axis here is the main pathway which connects the center of the monument and the center of the entrance. This is a powerful device which organize all the other spaces, garden and other buildings in the entire complex. If the axis change, the entire composition will change in this architecture. We will see certain attributes of an axis. Since an axis is essentially a linear condition, it has qualities of length and direction and induces movement and promotes view along its path. Definition and emphasizing an axis. How an axis in architecture can be emphasized. That is what we are going to see now. For definition of axis, it must be terminated at both of its ends by a significant form or a space. If we do not have this termination at the end, the axis will be perceived infinite, it will not be strong. So it should have a space or a structure on either end to make the axis more strong. The notion of an axis can be reinforced by defining the edges along its length. These edges can be simply a line on the ground plane or a vertical plane. We can make the axis more strong without the termination by making the edges more strong. In this case, you can have 2 elevated wall planes on either side of the movement, or it can be a simple floor plane which will make the axis more powerful. The axis can also be established simply by symmetrical arrangement of forms and spaces on either side, like what you see here. Now we will see certain examples of architecture where we have axis emphasized by various methods. Most of the Islamic architecture in India, you have a very strong central axis which connects the main structure, its center and the entrance. This is the case of Humayun's tomb. The main axis leads to the center of the tomb from the entrance, and everything else, the floor and the garden on either side, what is called as a charbagh, everything will be perfectly symmetrical on either side of this axis, which makes the axis more stronger, which makes the view towards center more stronger. Not only in Islamic architecture, even in Hindu traditional architecture, most of the examples there will be a central main axis which will be empowered by the structures arranged in the same line, and also the other structures on either side mostly will be arranged to empower the central axis, because the central axis is the one which connects the entrance to the main deity of the temples. The axis can happen not only in the building level, it can happen in the city planning level or in the settlement level. Here you see an example of temple settlement where you have 2 axes. The axis is empowered by the structures, the way of arrangement of it. Another example of axis strengthened by the pathway and by termination at the main structure. Now we will see certain ways of terminating an axis. The terminating element of an axis serve to give a visual thrust. These culminating elements can be of any of the following types. Point in space establish either a vertical linear element or a centralized building form, like what you see here. The obliques in Egyptian architecture serve this purpose. The vertical tall obliques used to empower the axis or the movement path. Other way of empowering the axis, other way of terminating it is by keeping a vertical plane perpendicular to the axis. Here you have the building facade which is perpendicular to the axis direction. Without a structure also, an axis can be terminated. You can have a plaza at the end of a axis. You have many examples of European architecture where you have a well defined space, generally centralized, that ends in a axis. An axis can be terminated by a gateway that open outwards towards a view or a vista beyond, like what is shown here. Now we will see certain architectural example of how an axis is being empowered by termination and other methods. The main street of the temple of Thiruvananthapuram, where the axis is empowered by the main gopuram of the temple and also by the facade of the palace on one side. Not only this example, most of the temple streets in Indian architecture, the gopuram acts as the main empowering element of the axis. Without the gopuram, the pathway won't be more strong and interesting. It's an interesting example of how an axis is empowered by just presence of two columns instead of being a big archway. The axis here is empowered by the structures on either side also. By creating a vertical plane on either side, the central axis, central movement is empowered, it's made interesting. Without this structure on either side and without these two pillars, the axis won't be defined at all. Now we will see in detail about the aspect called symmetry. What is a symmetry? A symmetrical condition requires the balanced arrangement of equivalent pattern of form and space on opposite sides of a dividing line or a plane or about a central axis. If you see, actually both the aspects of axis and symmetry are related to each other, they are inseparable. There are two kinds of symmetry, what is called as the bilateral symmetry and the radial symmetry. In bilateral symmetry, you have central axis and you have the two sides similar to each other. It can be a simple path with a single element repeating on either side, or it can be a path, an axis with varieties of structures but in a similar manner on opposite sides. An axis can be radial also, like what is shown here. Two perpendicular axes can cross each other so as to make the center more powerful. Most of the traditional religious architecture in India and abroad will be an example for this radial symmetry with two perpendicular axes. And also an axis can be more than two in number, like what you see here, a radial symmetry. Now we will see certain architectural example of application of axis and symmetry. The example of Salk Institute by architect Louis Kahn, a very simple and beautiful example of how an axis is empowered by the symmetry of the institution building on either side. If the symmetry is broken in this facade of these buildings, the beauty of this axis will be broken. An example of British Council Library by architect Charles Correa in Delhi. Again you have a facade. The forms in the facade, the openings and the building form and the garden, everything is symmetrical on either side, empowering the axis. Baha'i temple, here it is an example of the radial symmetry, where you don't have a single central axis, you have axis on all the radiating sides. The building looks the same from all the directions because you have symmetry on all the directions. Example of Milan Cathedral in Italy. Most of the European cathedrals, the Gothic cathedrals and even contemporary cathedrals, the facade will be perfectly symmetrical. Even the planning of the architecture will be symmetrical. The case of Taj Mahal actually doesn't have symmetry on one line, it has symmetry on more than two axes. If you see the facade from the front or the sides or even from the diagonal like what is shown in this picture, it will be symmetrical in all the directions. This is an example for the radial symmetry again. Again this example of Humayun's tomb in Delhi, example of a radial symmetry. Example of the planning of temple architecture, again example of radial symmetry. Symmetry can be applied not only in building and campuses, it can, the entire city or a settlement can be planned according to symmetry and axis. The example of Forbidden City in Beijing has a strong central axis and movement path which leads to the center of the settlement, and everything else, all the buildings around is arranged in a symmetrical manner. Another example of symmetry and axis. The axis here is empowered by the obliques like what is discussed before. The axis here is important because it leads to the main altar of the cathedral in the front here. The axis and symmetry is more empowered by the colonnade on the either side. Without this obliques and without this colonnade on either side, the movement here, the axis here won't be powerful and interesting. Now we will see in detail about the principle what is called as hierarchy. What is a hierarchy? Most of architectural compositions have varieties of form and spaces with different function and levels of importance and meanings. For a form or space to be articulated as being important, it must be given emphasis through size or shape or its location. This articulation of importance is called hierarchy. A sketch shows a design through which hierarchy and importance is created through the center of the cathedral space. Most of the religious monuments, which will be very large scale, has many spaces inside it. Out of all the spaces, the main central altar will be the most important space. So, how it can be empowered and signified? It can be empowered and signified through the hierarchy of the form, both in the interior and also the exterior. Then this example of Hagia Sophia in Istanbul, you see many forms here, but one form is very different and it is shown as a main powerful form, that is the central dome. Just by the positioning of it and the shape of it, the importance of the space below is emphasized. That is an example of hierarchy. Hierarchy or the importance can be shown in many ways. Hierarchy can be shown by size or by shape or by just the location and placement of it. Hierarchy by size. A form or space may dominate an architectural composition by being significantly different in size from all the other elements in the composition, like what is shown in this picture. Imagining this to be various parts of spaces of a bigger architectural composition, one part seems to be very important and also another part seems to be very important. This importance or a feel of hierarchy is created just by varying the size of the part. Here it is larger, here it is smaller. Both the changes creates importance to the arrangement. So, all these space seems to be subordinate to these two spaces. This is an example of hierarchy or manipulation to the size of the element. Now, we will see how the hierarchy can be created by changing the shape. In this composition, you see many spaces or objects, out of which only two seems to be important because the shape changes or the arrangement of the shape changes. Hierarchy can be created without changing the shape and size, just by placement of it. In this case, the shape is not different, the size is not different, just by the placing the shape in a different location, an importance can be created. Now, we will see examples of architecture which have applications of all these hierarchical methods. The plan of Jawahar Kala Kendra in Jaipur, where the main administrative building is shown important just by keeping it apart from the main composition of the planning, the 9 squares. In the Louvre pyramid, the form is very unique and that uniqueness creates a significance or a hierarchy in the entire composition. Out of this entire facade, one part seems to be very important. This importance or hierarchy is just created by the scale of it. All the arches in comparison with this main arch is smaller. That is why the importance is created. Not only in buildings, even in cityscapes, certain structures and architecture can be shown important just by manipulating the size of it. In this case, the scale of the Florence Cathedral in the Florence city is shown very important just because of the scale of it and also by the shape of the dome. There is an interesting example of how a hierarchy can be created by decrease in size also. The series of gopurams receding towards the center, the main central shikara is the smallest in the entire row. So, hierarchy can be created by reducing sizes also. If you see the planning of the assembly building in Chandigarh by architect Le Corbusier, the form is a rectilinear form, but you have one part which is a circle, and that change in the shape creates importance and creates a hierarchy, because this is the main assembly hall of the entire building. That change in shape is shown in the building view also. So if somebody perceives the building from outside, they will know the importance of this shape and the space below. Now we will discuss about the principle of what is called as datum. A datum refers to a line or a plane or a volume of reference to which other elements in the composition can relate to. It organizes a random pattern of elements through its regularity and continuity. In architecture, this aspect of datum is very important, because you have examples of architecture where you have many parts in a building. All the parts has to be combined or brought together in the same platform under a same datum to make it as a single unified composition. There are varieties of ways of doing it. There are different tools of creating a datum. A line can be a datum, or an architectural plane or architectural volume can be a datum. We will see it one by one. Given a random organization of dissimilar elements, a datum can organize the elements in the following ways. First, a line can cut through or form a common edge for the pattern, while a grid of line can form a neutral unifying field for the pattern. Here the main organizing element of the composition is the central line or the central movement path, which unifies the composition. Without the central line, the composition may not be harmonious. Creating a datum through a plane can gather the pattern of elements beneath it or serve as an encompassing background for the element and frame them as a field. A volume can collect the pattern of elements within it. A volume can collect the pattern of elements within its boundaries or organize them along its perimeter, like what is shown here. The different elements or spaces within an architecture is unified by a volume around it. Now we will see certain architectural examples of how organization or unification can be done by datum. These structures here you see is being unified by certain elements here. One is the platform or the plinth on which the building is kept. If you imagine the same building without this plinth, which act as a datum, all the structures here will look separate and disconnected to each other. So the plinth acts as a unifying element. In this case of a Japanese temple, the bounding corridor around the building acts as a unifying element, without which all the temple structures will look separate and disconnected to each other. In elevation, this corridor connects all the separate building into a unified composition. Even a roof plane can do the same activity of connecting the disconnected spaces, like what is shown in this picture. A single roof plane which connects and unifies the activities happening below the shaded roof. Now we will see in detail about the aspect of rhythm or repetition in architecture. Again, as we discussed before, all this principle is not only there in architecture, it is applicable in any form of art like sculpture also. If you have repetition in a sculpture or an art, it brings beauty to it. Rhythm refers to any movement characterized by a pattern, recurrence of elements or motifs at regular intervals. The movement may be of our eyes or our body through a sequence of space. Rhythm incorporates repetition as a device to organize forms and spaces in architecture. We will see some examples of rhythm in architecture. Architectural elements, most of them are repetitive, like what is discussed before. Here in this case, the columns repeat in a sequence which creates a rhythm. The colonnade of St. Peter's Cathedral, St. Peter's Square. Almost all building types incorporate elements that are by their nature repetitive. For example, beams and columns repeat themselves. Even windows and doors recurs in a building surface. Spaces also recur inside the building to repeat itself. Repetition in building need not be perfectly identical. They may just share a common trait or a common denominator. Repetition in architecture can be created by repeating the same shape but in a different scale, like what is shown in the first example. Either it is a column or a window, you repeat the same form but in a different scale. But in all cases it may not be possible, so you may have different shapes. In that case you can create a repetition or a rhythm by maintaining the same size of it irrespective of the form of the shape. If neither the size nor the shape is possible as a similar one, then you can create rhythm or similarity or repetition through details in the shapes like what is shown here. Now we will see architectural examples of applications of the repetition principles now. The Lion Station by architect Calatrava, where you have a rhythm in the facade by the architectural element, that is the column, which is of the same shape and same size, but in the same facade you see a repetition of the structural member here of same shape but in a different size. Even windows can be a rhythmic element like what is seen in the hostel building of MIT by architect Alvarado. One of the best examples of rhythm in the building form, there is only one element that is repeated in this entire composition, which is a shell like a petal of a lotus, but it changes in size, it changes in its proportion, but the main form is not changed, which creates a repetition in the rhythm. Now we will summarize the discussion that we did. We saw what are the main principles of architectural organization. We saw them one by one in detail: the axis, symmetry, hierarchy, datum and repetition. We saw how axis and symmetry, being the very basic and important principle, have been applied in historical architecture. We saw through hierarchy how a space can be made important or insignificant, both in scale of architecture and also in scale of a city. And we saw in detail about what does a datum means, how datum can unify the various spaces in an architectural composition, and we saw how this aspect of repetition or rhythm can be applied in building. We have some questions to recall the discussion. What are the various ordering principles of architecture? What is the relation between axis and symmetry? Explain with the building examples. What is meant by datum? How it functions in architecture? The main reference book for this discussion is the book titled Architecture, Form, Space and Order by Francis D. Kitching. Thank you.